maybe you can tell from all these books, but I have a lot going on right now. The end of the semester is so stressful, and I feel like I can't keep up. Oh gosh.
Clearly, Thelma is struggling with a lot of stressors. Let's talk about what this means.
Stressors are experiences that induce the stress response. When the human body is exposed to threat or harm, the result is a cluster of physiological changes generally referred to as the stress response.
My stressors include, but are not limited to, my friend, Patrice, in chess club, is always being a no-shit, and I have 3 exams tomorrow. And as for my stress response, well, I can't stop sweating, and every time I think of my tests, my heart beats really, really fast, and I have headaches. As for Patrice, well, I'm ready to fight her.
A lot of things contribute to stress. Stress only occurs if your brain perceives a situation as stressful. If it doesn't, stress won't occur. Thelma's brain clearly thinks her situation is actually threatening or stressful. Over time, important relationships affect an individual's physiological response to stressors. For example, since Thelma's relationship with Patrice is continuously negative, it affects Thelma's stress response. When Thelma sees Patrice, she instantly feels more tense and feels her heart rate increase. After hanging out with her, Thelma is so on edge that something as simple as spilling her coffee sends her over the edge. In a study done on baby mice, it was shown that an enriched environment, especially early in life, has positive cognitive effects. This enriched environment induced protection against the effects of chronic mild stress on behavior and neuroplasticity. These positive effects of environmental enrichment stayed with the mice even after they were taken out of their enriched environment. A study about rat pups also demonstrated the positive effects of touch. Rats that had been handled as pups displayed smaller amounts of glucocorticoids in response to stressors. Here's a question to think about. What would make up an enriched environment, stimulate the neuroplasticity, and protect against stress for a human baby? So now we know what contributes to stress and what can be done to reduce its effects. What happens in the brain when stress occurs? Stress stimulates the anterior pituitary adrenal cortex system. The corticotropin-releasing hormone, CRH, is activated by stress. In turn, CRH stimulates ACTH, or adrenocorticotropin hormone, from the pituitary gland, which releases the stress hormone cortisol, a glucocorticoid, from the adrenal gland. Stress has other effects on the body as well. According to our research, there is some validity to the concept of stress eating. There are a couple of neuropeptides associated with stress and responses to stress, those being neuropeptide Y and neuropeptide relaxin-3. Relaxin-3, abbreviated RLN3, is involved in stress and appetite, and is predominantly lies in the nucleus incertus, or NI for short, which is a cluster of about 12 nuclei that's located within the caudal portion of the brainstem. Its receptor is RXFP3, and the signaling of these are involved in the regulation of feeding, motivated behaviors, and stress and anxiety. Therefore, those already prone to binge eating increase this habit under stressful situations. If you find yourself eating more when you're stressed, you're not alone. As for neuropeptide Y, it's crucial for the stress adaptation process, more specifically the termination process of the stress response. So what are the greater implications of stress in the body? One study found that exposure to negative and stressful events in kids and HPA genetic risk factors interact and predict weakened amygdala resting state functional connectivity. As we discussed in class earlier in the year, the amygdala is very important in emotional regulation. So we can infer that a lot of stress early in life may cause emotional problems later in life. Emotional problems can then interact with stress to cause people to have more somatic health complaints. One study found that people with higher levels of distress and negative affect report more somatic complaints. For example, Thelma has been experiencing headaches. Finally, chronic elevations in glucocorticoids may contribute to degenerative changes in the brain. Obviously, many bad things occur when your body is exposed to extended periods of stress. So, what can be done? There are pharmacological methods that can reduce high levels of stress-induced glucocorticoids. In the short term, and in certain situations, these may be best. However, for some people, psychotherapy and biofeedback would be better because these approaches can reduce the stress response to psychological experiences. So, if you're experiencing a lot of stress, there is hope. Discuss some of the methods you use throughout the day to cope with stress in comparison to neuropharmacological techniques, like drugs that are antagonists for the neuropeptides we talked about. In your discussion, think about which of these techniques are more likely to facilitate neuroplasticity and why.